Ask anyone to name the largest steam locomotive ever built, and you'll get the same answer. Big Boy. It's the most recognized steam engine on the planet. And in 2019, Union Pacific proved it by bringing one back to life. But the heaviest steam locomotive ever placed on rails wasn't a Big Boy. The most powerful wasn't either. That record belongs to a machine built in 1941 to drag coal over the brutal grades of the Allegheny Mountains. A locomotive so enormous it made Big Boy look small, and yet today, most people have never heard of it. The question isn't just why it was forgotten, it's how Big Boy became the legend instead. In May 2019, Union Pacific number 4014 moved under its own steam for the first time in nearly 6 decades, completing a multi-year restoration that captured national attention. As the locomotive traveled across the American West, massive crowds lined the tracks. Families parked along highway shoulders, filled overpasses, and gathered at small-town stations just to watch the engine pass. In its first year back on the rails, Number 4014's public debut at the Union Pacific Railroad Museum attracted more than 200,000 visitors. This modern public spectacle reflects a deep connection to a name that has dominated rail history for generations. The public image of the Big Boy was not left to chance. Union Pacific actively constructed it. Starting in 1941, when the American Locomotive Company delivered the first locomotives, the railroad's public relations department promoted them as the ultimate symbols of American industrial strength. Promotional pamphlets and industry journals ran stories featuring the title Big Boy, a name that was simple, powerful, and easy to remember. This strategic promotion continued even as the steam era ended. In 1955, Union Pacific established a preservation committee to protect its history. While other major railroads quickly sent their largest steam engines to the scrapyards to make way for diesel fleets, Union Pacific took a different path, preserving 8 of the 12 Big Boys and placing them in prominent museums across the country. These displays kept the locomotives visible to the public for decades. When the railroad's heritage team began rebuilding number 4014, they tapped into this existing familiarity. The restoration was not just a technical project, but a major public event. By keeping these engines in the public eye for 80 years, Union Pacific ensured that when people think of steam power, they think of the Big Boy first. In December 1941, just 2 days after the United States entered the Second World War, a different class of steam giant rolled out of the Lima Locomotive Works in Ohio. This was the H8, a massive articulated locomotive designed for the Chesapeake and Ohio Railway. Though it emerged in the exact same wartime era as Union Pacific's Big Boy, the H8 was built to solve a fundamentally different operational crisis. Union Pacific needed to drag long, mixed freight trains over the expansive dry grades of the Wasatch Range. The Chesapeake in Ohio, by contrast, was a coal road. Its lifeline was the heavy, dense, bituminous coal mined in the Appalachian fields of West Virginia and Kentucky, which had to be hauled eastward over the Allegheny Mountains to the coastal ports of Virginia. For decades, the C&O relied on slow, heavy-drag locomotives like the 2882 to crawl up these steep mountain grades. But by the late 1930s, the railroad needed more than just raw pulling power, it needed speed. The goal was to move 11,000-ton coal trains over the mountains at sustained speeds, keeping the main line clear and the coal flowing to support the nation's rapidly expanding wartime industries. To achieve this, the C&O bypassed the traditional locomotive builders and partnered with Lima, a manufacturer famous for its superpower design philosophy. Lima's engineers did not focus solely on tractive effort. Instead, they prioritized boiler capacity and steam generation, designing a locomotive that could produce immense power at high speeds. The result was a distinctive 2-to-6 and 6-to-6 wheel arrangement, featuring a massive 6-wheel trailing truck designed specifically to support an unprecedentedly large firebox. Officially named the Allegheny, this locomotive was built not just to haul, but to run. engineered specifically to conquer the grueling 2.2% grades of the Allegheny Division. The Chesapeake in Ohio was, at its core, a coal road. Its entire infrastructure was built to support the massive outflow of fuel from the Appalachian mines to the industrial centers of the East. The coal fields of West Virginia and Kentucky produced millions of tons of high-grade bituminous coal every year, all of which had to travel east to the coastal ports of Virginia. Standing directly in the path of this essential supply line was the formidable barrier of the Allegheny Mountains, a territory of sharp curves, narrow river valleys, and unforgiving climbs. The most punishing bottleneck on the entire system was the Allegheny Division, where heavy trains were forced to claw their way up a sustained 2.2% grade. For decades, the railroad moved this immense tonnage using traditional heavy drag steam locomotives. Engines like the compound 2662 and 2882 mallets were the workhorses of the mountains. These machines were designed for brute strength at walking speeds. While they were capable of pulling heavy coal trains, they did so at an agonizing crawl, often averaging less than 15 miles per hour on the uphill climbs. As train lengths grew, these older mallets required helper engines at the rear, doubling the crew requirements and consuming massive amounts of water and coal just to keep the traffic moving. It was a slow, deliberate system of moving freight, but as long as demand remained steady, it was functional. By the late 1930s, this slow-drag operational model was collapsing. The demand for industrial coal was soaring as American factories began preparing for wartime production. The railroad faced a logistical crisis. Slow-moving coal trains were clogging the main line, creating massive traffic jams in the mountain passes. The C&O could no longer afford to let its coal trains creep over the grade. They needed a locomotive that could start an 11,000-ton train on a steep mountain grade, accelerate it, and maintain high speeds once it cleared the crest. This operational crisis demanded a complete engineering departure. The railroad needed a machine that possessed an unprecedented combination of starting tractive effort and high-speed steam production. It had to be an engine designed to conquer the grade through continuous, high-speed power rather than slow brute force. To understand which locomotive was truly the largest, we must look at weight, a category where the Allegheny holds a historic yet contested record. The H8 is frequently claimed as the heaviest steam locomotive ever placed on rails, a title that directly challenges the popular reign of the big boy. But in locomotive engineering, weight is far from a simple measurement, and it depends entirely on where you draw the boundary. The core of the Allegheny's claim lies in its engine-only weight, the physical mass of the locomotive itself, excluding the coal and water carried in the tender. Under this metric, the H8's massive frame, heavy-duty boiler, and six-wheel trailing truck push its weight to an immense engine-only figure of 778,200 pounds. By comparison, Union Pacific's Big Boy, despite its longer wheelbase, officially weighed in at 772,250 pounds. This margin of nearly 6,000 pounds gives the Allegheny the heaviest single engine ever constructed. Yet this record shifts the moment other methods of measurement are applied. When these locomotives are coupled to their tenders and fully loaded with fuel and water, the comparison becomes far more complex. The Big Boy carried a massive tender which, when fully filled with coal and 24,000 gallons of water, brought the combined weight of the engine and tender to more than 1,208,000 pounds. Depending on which build batch of Alleghenies is compared, the Union Pacific giant either matches its eastern rival or exceeds it. In terms of total operational weight, the Big Boy regains its status as the heavier machine, showing how easily engineering records can change depending on how the scale is set. While weight can be measured in different ways, the physical work a locomotive performs on the line is ultimately determined by its power output. In railroad engineering, the definitive test of a locomotive's capability is drawbar horsepower. This term describes the actual, usable power available at the coupler to pull a train, after accounting for all mechanical friction and internal losses. It is the direct measure of work delivered to the rails. In this category, the Allegheny established a benchmark that no other steam locomotive in history would surpass. In the summer of 1945, a test crew placed engine number 1606 on a dynamometer car to measure its performance under load. As the locomotive hauled a heavy train at a sustained speed of 45 miles per hour, the recording equipment registered a peak output of roughly 7,500 drawbar horsepower. This figure stands as the highest documented drawbar horsepower ever recorded for any steam locomotive. Even Union Pacific's Big Boy, despite its legendary reputation and immense physical length, topped out at a documented 6,290 drawbar horsepower under similar testing conditions. The Allegheny's output exceeded its western rival by more than 1,200 horsepower, a margin of nearly 20%. This record matters because it shifts the focus from physical dimensions to actual pulling performance. The H8 was a formidable power plant on wheels, engineered specifically for sustained output at speed. Its massive boiler and oversized firebox generated steam rapidly enough to maintain this level of continuous work. While other locomotives might claim greater length, the Allegheny remains the undisputed king of high-speed, heavy-haul steam power. Union Pacific's Big Boy holds physical and operational advantages that prevent any simple comparison. When measured from coupler to coupler with its tender, the Big Boy extends to 138 feet, outstretching the Allegheny by 5 feet. This physical length gave the Western locomotive an unmatched presence on the rails, allowing it to navigate the sweeping curves of the Wasatch Range with remarkable stability. Beyond physical size, the Big Boy possessed a clear advantage in starting power. It was designed to exert 135,375 pounds of starting tractive effort compared to the Allegheny's 118,800 pounds. When starting a heavy train on a steep grade, this initial launch capability was essential. The Allegheny's impressive continuous horsepower at speed could not erase the Big Boy's superior starting strength off the line. This comparison shows that deciding which locomotive was truly the largest depends entirely on the metric of choice. If the standard is physical length, and the raw power required to get thousands of tons of freight moving from a dead stop, the Big Boy claims the advantage. The rivalry between these two giants shows that engineering records only make sense when we define exactly what we are measuring. Each locomotive was perfectly shaped for the particular demands of its home rails, and the title of biggest depends entirely on which criteria we choose to prioritize. In late 1942, as the first batch of H8s rolled onto Chesapeake and Ohio tracks, a quiet crisis brewed in the railroad's engineering department. Chief Mechanical Officer Bill McIntyre raised concerns that the new locomotives exceeded the 78-ton axle load limit designed for the Allegheny division. Overweight engines risked destroying the track. Lima's chief engineer, Jack Ladd, countered that the engine-only weight was safe. This disagreement triggered a paper trail of internal memos, specifically C&O Document 2345 and Lima Memo L12. From July 1942 to March 1943, both sides exchanged conflicting weighbridge receipts. C&O measured the engine alone at 508 tons, while Lima claimed 511 tons. The 3-ton discrepancy came down to water trapped in the coal shakers. The dispute forced a joint technical meeting at Lima's Ohio factory on April 12, 1943. An independent third-party weighbridge, operated by the Railroad Safety Board, measured the engine at 506 tons. This officially met the C&O's contract specifications, but the close margin meant a full tender pushed the axle loads to the absolute limit. This archival record shows that the H8's reputation as an overbuilt, massive machine was not a legend born years later, but a real-time controversy managed by the men who built and bought it. While the Allegheny was engineered to fly with heavy loads at 45 miles per hour, its actual assignment was far more mundane. The Chesapeake and Ohio put this high-speed machine to work dragging slow coal trains over the mountains, rarely calling on the qualities that made it exceptional. The men who operated the H8 felt this mismatch firsthand. Engineer Thomas Sullivan, who logged 1,200 miles on the Allegheny Division, described the locomotive as a runaway freight horse that never got a chance to show its speed. He noted that the heavy coal drags, the steep grades, and the strict timetables forced crews to constantly throttle the massive engine back. At the same time, the locomotive's hunger worked against its assignment. Fireman William Kelly recalled that the oversized firebox required up to 10,000 pounds of coal every hour to sustain its rated power. This rate consumed fuel faster than the division's coaling stations could supply it, leading to frequent fuel starvation stops where the crew had to idle the engine for hours. Instead of running fast across the division, the locomotive spent its career grinding uphill at 15 miles per hour. It was a masterpiece of high-speed engineering operating in a slow-drag environment that did not demand its greatest strengths. The mismatch between the Allegheny's high-speed design and its slow mountain assignments was never resolved on the rails. Instead, a shift in technology made the question obsolete almost overnight. By the late 1940s, the economic realities of American railroading were changing. The diesel-electric locomotive, once reserved for yard switching and passenger runs, had matured into a reliable, highly productive option for heavy freight. The Chesapeake and Ohio resisted this transition longer than many of its peers, largely because of its close financial ties to the coal industry. Burning coal in massive steam locomotives was a matter of corporate loyalty, but the economic advantages of the new diesel units could not be ignored. A single diesel locomotive required less maintenance, did not need constant stops for water, and could be coupled with other units to match any train size without adding extra crews. In 1950, the C&O began its transition to diesel power in earnest. The impact on the steam fleet was immediate and total. The H8 Alleghenies, despite being among the newest and most powerful locomotives on the roster, were the first to feel the pressure. Their complex machinery and heavy axle loads made them expensive to maintain compared to the standard diesel units. Within 2 years of the diesel program's launch, the C&O began pulling the Alleghenies from active service. By 1952, the railroad had withdrawn a significant portion of the H8 class from the mountain divisions. By 1953, the entire class of 60 locomotives was out of service. A fleet of locomotives built to handle the heaviest loads for decades was sidelined after only 10 to 12 years of operation. This rapid retirement was not a reflection of mechanical failure. The Allegheny did everything its designers asked of it, delivering unmatched horsepower on the mountain climbs. Its career was cut short simply by the timing of its birth. The H8 entered service at the absolute peak of steam technology, a moment when the coal-fired locomotive had reached its physical limits. It was a victim of historical obsolescence, sidelined before it could fully establish its place in operational history. The era of steam ended before the machine could truly define itself on the rails. Between 1941 and 1943, the Lima Locomotive Works built 60 H8 Alleghenies. These locomotives represented the pinnacle of steam engineering on the Chesapeake and Ohio, yet by the mid-1950s, 58 of them had been sold to scrap yards, sliced apart by blowtorches, and melted down to make steel for a new generation of diesel-powered trains. This rapid destruction of almost the entire fleet left a massive gap in physical history. Only 2 of these giants escaped the scrap lines to survive as static museum exhibits, and neither is operable today. One was preserved at the Virginia Museum of Transportation, and the other found a home at the B&O Railroad Museum. For a locomotive to maintain a living identity in the public mind, it needs to run. But the surviving Alleghenies are locked in place, facing structural, financial, and physical barriers that make future operation nearly impossible. To restore either locomotive to service, a museum would first have to complete a rigorous federal inspection. Under modern safety regulations, this requires a complete boiler certification lasting 1,472 days, involving extensive ultrasonic testing of the thick steel boiler plates. Refurbishing or replacing these massive pressurized steam systems is estimated to cost between $3 and $5 million per engine. Even if a museum secured that funding, the physical infrastructure of modern railroading cannot support a machine of this scale. The Allegheny's appetite was designed for the heavy-haul coal fields of the 1940s. Operating at capacity, the firebox consumes up to 10,000 pounds of coal every hour to sustain its rated power. Running a locomotive with this rate of fuel consumption requires specialized coaling towers, active coal mines, and high-capacity water facilities, systems that have been completely dismantled across the country over the last 70 years. Aside from the mechanical hurdles, the Allegheny's physical weight works against its survival. The locomotive's 78-ton axle load exceeds the track class limits of most tourist and heritage lines, which are typically restricted to 75 tons. Running the H8 on these lighter tracks would cause severe, immediate damage to the rail bed and ties. Without a dedicated corporate advocate such as a major modern railroad, willing to fund millions of dollars in track upgrades and mechanical restoration, the surviving Alleghenys are destined to remain permanent museum fixtures. They are massive, silent steel structures, physically present but completely separated from the active rails they were built to conquer. The division between history and legend often comes down to institutional decisions made decades ago. While other railroads viewed their retired steam fleets as liabilities to be quickly cleared from the books, Union Pacific treated its largest locomotives as valuable corporate assets. In 1955, as diesel-electric locomotives took over the main lines, Union Pacific's Chief of Steam Operations, Robert H. Miller, convened a dedicated preservation committee. This group, consisting of engineers, museum curators, and public relations specialists, was tasked with identifying and saving the most significant pieces of the railroad's past before they met the scrapper's torch. Instead of saving a single token engine, the committee chose to preserve 8 big boys. They distributed these engines to museums across the country, placing them in major metropolitan areas where millions of visitors could see them. For over half a century, these static displays functioned as permanent, free advertisements for the company. The railroad did not simply abandon these machines to the elements. They actively supported local museums, coordinated public displays, and used the locomotive's immense physical presence to tell a story of industrial capability. This deliberate policy of long-term stewardship laid the groundwork for an unprecedented restoration. In 2013, Union Pacific reacquired number 4014 from a California museum. The railroad's heritage restoration team spent years completely rebuilding the locomotive at their shops in Cheyenne, Wyoming. When number 4014 returned to the rails in May 2019, it was not a volunteer-run effort, but a fully funded, corporate-backed operation. Union Pacific used its heritage fleet to connect its modern transportation system with its historic identity. This commitment to active stewardship transformed the big boy from a quiet mechanical relic into a living, breathing symbol of American railroading. The Allegheny may hold the documented records for drawbar horsepower and engine-only weight, but engineering numbers alone cannot sustain a legacy. The big boy dominates the public imagination because Union Pacific chose to actively protect, market, and run its history. Ultimately, legends are not built on the drafting table or measured on a scale. They are kept alive on the rails. The fame of the big boy is no manufactured illusion. The 4000 class locomotives earned their reputation through daily performance on some of the most challenging main lines in North America, hauling critical supplies through severe winters and across unforgiving mountain divides. Dismissing the big boy as a product of public relations ignores the engineering triumph it represents. On the rails of the Wasatch Range, physical length and starting power decided success. The Big Boy was designed specifically to start an 8,500-ton train from a dead stop on a steep mountain grade without helper engines. Its 138 feet of physical length, coupled with 135,375 pounds of starting tractive effort, was a functional, heavy-duty tool that kept American wartime freight moving over the Continental Divide when industrial output was pushed to its absolute limit. While the Allegheny excelled in sustained horsepower at high speeds, the Big Boy was the more versatile machine, proving reliable over decades of heavy service. Union Pacific's decision to preserve and eventually run number 4014 validated a reputation forged in coal, steel, and steam, proving that its physical survival was earned on the merits of its design. Both engines deserve their place in the history of steam development. Ultimately, the title of biggest depends entirely on which engineering problems a railroad had to solve. The Allegheny remains a historic benchmark in continuous power, but the Big Boy stands as a monument to starting strength, endurance, and a railroad that kept its history alive. In the end, history does not belong to the heaviest machine or the highest horsepower. It belongs to the stories we actively choose to keep alive. While engineering created these iron giants, it is stewardship that decides which ones survive in our collective imagination. The legend of the rails is not just built, it is curated. Which giant holds your imagination? Share your thoughts below.